Okay, today we're solving system of linear equations with something called the elimination method or the addition method. Books call it both names, elimination or addition. Okay? We've learned how to solve them using the graphing method, and we found it's time consuming and it's not always accurate. Yesterday we learned the substitution, also known as the transitive property. And then the third method is called the elimination method. Okay? Meaning if we add A and C together, it will still be equivalent to B and D. If A equals B, C equals D, then A plus C equals B plus D. All right. For now, you're not going to be writing this line. I don't think we need to write this part of it, okay? And my PowerPoint's going to write the equation twice. You don't need to do that. Okay, write the equation down now. Okay? Now, what we are looking for is an additive inverse. Generally, we use this method when the equations are given to us in standard form with x and y on the same side. What we have to do is line our equations up so our x's are lined up, our y's are lined up vertically, and our constant terms are lined up, and our equal signs are lined up. Okay? It doesn't work if you have one equation in y equals form. So once I do that, using the elimination method, or the addition method as some books call us, we could just add straight up and down. 2x plus 3x makes how many x's? 5x. Positive y minus y, what does that make? 0y, right? 6 plus 4 is 10. So what happened here is I lined it up with its additive inverse. Everybody say additive inverse. So because we want to eliminate a variable. We call it elimination method because we eliminate a variable. We call it addition method because we're adding positive y and negative y. And now we can solve. Divide both sides by 5. X equals 2. And we are done. Okay, now we have to find the y. Sorry, we're not really done. We're just done finding our x. So now that we know our x, we go back to either original equation, and we're going to substitute it in. So 2 times 2 plus the y equals 6. That becomes 4 plus y equals 6. Subtract 4, and y is 2. My solution is 2, 2. Now, we can check that with each equation. On a test, you should be doing this. 2 times 2 plus 2, does that make 6? 2 times 2 is 4, plus 2 is 6. 6 equals 6. 3 times 2 is? 6. Minus 2 is 4. Good. So it works for both. Yes, I saw there was a hand up. Okay. All right. I want you to pause the recording and try the next one on your own. How about Veronica?
So we added them together, right?
And what did you get?
I got 4y equals 8.
Okay, but so what? How did you get that? What happened?
Because the x and negative x, I crossed it out.
What are they called?
Eliminate. Yeah.
What are they called, everybody? What? Additive inverse. Everybody say that. So.
Additive inverse.
Okay, so they cross cancel, and what did you get?
So then 4y equals 8.
We don't cross cancel. They cancel out. Okay. 4y equals 8.
And then divide both sides by 4.
And y equals
2.
good. So then I used it in either original equation, and I substitute in, and we should have gotten x plus 6 equals 5, subtracting the 6, and x is equal to negative 1. Okay, questions? Okay, what is my solution? What is my solution, David?
The solution is
negative 1, 2. Does it work in both equations? Yes.
And you have to write it through the homework. Let's say you have to write the one on top. And then
No, I said you don't have to do that. Write it twice, not in the notes or at homework. Okay? Now, what we're doing is we have a problem here. We have a problem here, and that problem is that my equations are not in standard form. Okay, so what would we need to do? They're not in standard form. Ashley. Yeah, we're going to have to put the y equals 3x plus 4. We're going to have to make sure. What do I need to do to get that into standard form? I'm subtracting 3x. I'm subtracting 3x. And we get negative 3x plus y equals 4. So my two equations are 2x minus y equals 5. Negative 3x plus y equals 4. Cancel, we're left with negative x equals 9. So x is equal to negative 9. Right? Okay, questions? And then I go back to either original equation. 2x minus y equals 5. 2 times negative 9 minus y equals 5. Negative 18 minus y equals 5. Add 18. Add 18. Negative y equals 23. So y equals negative 23. So my solution is negative 9, negative 23. Questions? Okay. Can I move on? Now, sometimes I really should have shown you the work like that. Sometimes, notice, is there an additive inverse here that we can do?
No.
So we have to manipulate an equation. David, which equation am I going to manipulate so one of the variables can become additive inverse? The second one. What am I going to multiply it by? By 2. Close. Not 1/2. Yes, Cameron? Negative 2. Now, I want you to show your work like this. Look what I'm doing. Write the two equations. The first one, I'm going to draw an arrow. And, well, they're just showing you how it doesn't work. This makes 3x. So, the first one, we're going to draw an arrow. And just write the equation as it was. The second one, when I have negative 2 times x, what do we get?
Negative 0.
Negative 2x. Negative 2 times negative 4y is positive 8y. And negative 2 times 9 is negative 18. All terms. You can do anything to an equation as long as you do it to all terms. Okay, so now what I've created is an additive inverse here. And I'm left with 11y equals negative 22. Divide by 11, divide by 11, and y is equal to negative 2. Go back to either original equation. X minus 4y equals 9. And I get x minus 4 times negative 2 equals 9. X plus 8 equals 9. Subtract 8. X equals 1. Ordered pair is 1, negative 2. Yes, Bryce?
Could you, if we did something to the first equation, could we,
Yeah, but then you would have to change both equations. To do anything, there's no way to get anything in the first equation to be the opposite of this. Okay? You have to get one variable to be additive inverses. That's the goal.
I was looking at the top of it.
Okay? So, let's now go to the hardest kind of problem. Can I move on? Okay. Well, I'm going to skip this. Okay, which one would we multiply here? The first equation or the second? Rami? And what would I multiply it by? What are we making additive inverses? Oh, we could do -1. Good. Is there anything else we could multiply it by? Max?
5.
By +5. So we could eliminate the x's by multiplying the bottom equation by -1 or the top equation by -1, but not both. Or we could eliminate the y's by multiplying the bottom equation by 5. Okay? So there's multiple ways to get there. Well, what happens in this situation when there's no possible, we have to look at common multiples. So to clear the x, I would need a common multiple of 10. To clear the y, I would need a common multiple of 6. What do you guys want to clear? Let's do the x because it's, I don't know, because it's first. So I'm going to need to get these to be opposites. The closest number that they both divide into is 10. So what am I multiplying the top sentence by, Cameron?
5.
By 5. I'm putting it in parentheses, and I'm drawing my arrow to the right. I want to see that arrow. And so the first term becomes
-10.
-10x
-10x plus 15y
plus 25. Good. And then what am I multiplying the bottom equation by, Bryce?
The bottom equation will start
2. And we end up with 10x.
Attention all students and staff, you have food to donate to our food drive today. Please bring the items to room 43 beside the parent center at the beginning of lunch today only. Thank you.
So 2 times 5x is,
10x.
and 2 times -2y is, stop, we're finishing. Okay. These eliminate, I'm left with, please do not pack up or you will stay longer. 11y equals 33, and then we get y, and I substitute in to either original. I said we do not pack up. Okay? And so we end up with x is equal to 2, 3. What did I just say? Don't pack up until I tell you to. Question. So it's pretty common that you have to multiply the top equation and bottom equation to get them to be additive inverses. Is everybody clear? Yeah?
Is there a reason they write the equation twice?
Well, this is what it is. Now let's start working with it.